Good morning, students. This is my officially first class on video lecture class on signals and systems. And in this class, without going into the definition of signals and systems, I will give examples in which we come across in our everyday life. And you try to identify which are all signals and which are all systems. In the next video lecture, I will exactly give you a definition for signals and systems. So here I have shown a diagram here. A fish swimming in a water trough or water tank. See, signals and systems are together. There is no identity for signals without system, or no identity for systems without signals. So relationship between signals and systems is like relationship between fish and water. So you can't take if fish is taken out of water, you know what happens. Or if fish is not in the tank, then what about the purity of water, you know. So they are very much interrelated. Signals and systems are very much interrelated, and they are together, and that is why I gave this example. Now I will give some examples which we come across in our everyday life, and you try to identify signals as well as systems. The example first I will take is that of a speaker. A speaker used in radio, television, etc. Speaker. So speaker is a good example for system. It is a system. As you know that it converts electrical signal to sound signal. The function of a speaker is to convert electrical signal to sound signal. So if this is speaker, then what is the input? The input is electrical input, that is voltage input. So it takes voltage input. Voltage input. On taking the voltage input, the speaker produces sound. And the sound is considered as output. So here the system is in the form of speaker. Speaker is constructed in a manner, and this is all, these two forms signals. So a voltage input signal and a sound output signal. So this is a best example to identify signals and systems. This is one example. Another example I want to take is that of clinical thermometer. Clinical thermometer. This is a clinical thermometer. So a clinical thermometer is another example for signals and system. So clinical thermometer is system. It has got a column of mercury inside a glass bulb, and it senses heat. So heat, temperature is the input. It takes temperature. On sensing the temperature, it undergoes change in the height. The mercury column height is going to be changed. So it responses, clinical thermometer responses in the form of height of the mercury column. So here temperature is considered as input signal, and the level mercury change in the mercury column level is considered as output. As you know that it is calibrated in terms of Celsius. So this is another example I want to take for signals and systems. So in this class I took these two examples. Now I will come to signals. What is a signal and what is a one-dimensional signal? I will take the example. Now I will take the example of temperature In the next class, I will give definition for signals and systems. Temperature in a room. Temperature in a room. Temperature in a room. Temperature is a physical variable. It is bound by physical laws. Hence, it is called as physical variable. So, temperature in a room, on what factor it depends? It is entirely dependent on time. Because temperature in the morning, temperature in the afternoon, or temperature in the night, that question arises. Hence, temperature in a room depends on time. And if you take this as room, in addition to time, there are also other parameters. I have to consider the point, where exactly I am measuring the temperature in the room. So it is designated by 3 coordinate axes: x axis, y axis, z axis. So in a 3-dimensional room. So this point is designated by 3 coordinate axes x, y, z. So temperature in a room depends on, in addition to time, the other 3 parameters. That exactly is location. Where exactly this point is located? Is it near to the roof, or is it near to the ground, or this point is it near to the windows? So location is also very important. And in addition to temperature, there are 3 other parameters: x, y, z. Then we used to say that temperature is a 4 variable parameter. 4 variables. So temperature, time, x, y, z coordinates. So there are 4 independent variables. So it's a 4 variable signal. But in our study of signals and system, we restrict ourselves to only one variable. That is, we don't consider x, y, z locations. So we consider only time, and we restrict ourselves only to the study of signals, which are one-dimensional signals. We call them as one-dimensional signal. One-dimensional. And in the next class, I will explain signals. So what exactly is the technical definition for a signal, and how signals are going to be classified. It is very interesting to know that signals can be classified as continuous signals or analog signals and discrete signals. I will come to the definition of continuous time signals and discrete signals in the next class. Thank you.